Hello Year 11 and welcome to our 6th and final video here for our series on probability. We're going to look at probability trees here that look a lot like tree diagrams, but they have weights on their branches. We write probabilities on the branches and we work out the probability of that outcome by multiplying the probability on each branch, right, that we from the start to the end. If we've got more than one outcome for our event, we can add the probabilities of each of the outcomes. Right, once we get to the end, multiply along the branches and then add up at the end. Let's see how this works. Now, consider this situation. Probability of rain on Saturday is 0.4, 40% chance of rain on Saturday, and a 60% chance of rain on Sunday. What's the probability of rain on both days? Now, we are going to draw here a tree diagram. You know what? I find it much easier to draw a nice neat diagram if I start at the end. Right, so I'm going to say we've got rain and not rain. Rain and not rain. I know it's going to look like that from experience. Now, this is going to be, this is for Saturday. And this is for Sunday. Rain here and not rain. Now I'll just draw my branches. Now on each branch, I'm just going to choose a different pen here. Let's use a little blue one. On each branch we need to write the probability. So the chance of rain on Saturday was 0.4. And I know that means that not rain on Saturday is 0.6. The chance of rain on Sunday is 0.6. Probably should have chosen different numbers here, but it doesn't matter. 0.4. It's a little confusing because it's being repeated. So 0.6 on Sunday for rain on Sunday, and 0.4 for no rain on Sunday. So, right, my sample space is I could have 2 days of rain. I could have a rainy Saturday and a dry Sunday. I could have a dry Saturday and a rainy Saturday. Dry Sunday, dry Saturday, rainy Sunday, and a dry Saturday, dry Sunday. The probability of each of these, we multiply along the branch. So this is 0.4 times 0.6 is 0.24. So my answer then, switch back to red here for a tick. Oops. The probability of 2 days of rain is 0.24. There's a 24% chance that it's going to rain all weekend. There we go. What's the probability of at least one dry day? Now, I could take those 3 other probabilities. They all have at least one dry day. I could work them out and add them together. But remember, where I see this phrase, at least, right, there's a clue there. That should tell us that we're going to use a complement. Right, where we see at least, we're probably going to efficiently find our answer using complementary events. Okay, so here we go. The complement of at least one dry day is no dry days, is 2 days of rain. We know that the probability, probability of 2 days of rain is 0.24. That means that the probability of the complement of that, now I'm just going to put a bar over both, which is not to say, don't confuse that with the probability of 2 not rainy days, right? I want the complement of that event is 1 minus 0.24 equals 0.76. Now that bar above becomes a little confusing. Anyway, that's the probability of at least one dry day is 1 minus the probability of 2 rainy days. Okay. Keep that in mind. When you see the words at least, you're probably going to use complementary events. Rolling along now. to our final example here for this unit on probability. I've got a ball, it's got 5 red balls, 3 white balls, 1 green ball. 2 balls taken out one at a time without replacement. What's the probability of 2 red balls? We're going to need to draw a tree diagram here, and we're going to have to be careful to draw it really neatly. So, first ball could be red, white, or green. If the first ball was red, then the second ball could also be red. Could be white, could be green. If the first ball was white, the second ball could be red, could be white, could be green. If the first ball was green, the second ball could be red, could be white, can't be green. Why not? Well, I've already taken it out. There's no more green balls left. Now, in situations like this, things get a little bit tricky, so watch carefully. Because the balls have been taken out and not replaced, right, then our probabilities sort of change as we go along. So, the probability the first ball is red, that's fine. It's 5 out of, add them up, 9. Oops, something's going wrong here. Oh, hang on. Okay, probability the first ball is red, 5 out of 9. Probability the first ball is white. It's doing funny things to me again, sorry people. Probability the first ball is white is 3 out of 9. I'm going to write that as 1 over 3 just to make things a little neat. 1/3. And the probability the first ball is green is 1 out of 9. Oops. Now if I add those 3 numbers together, I should get 9 out of 9 equals 1. Okay. Now, the probability of the second ball, so first ball was red. If the first ball's red, what's the probability that the second ball is red? Well, there are now only 4 red balls in that bag out of a total of 8 balls, right? We took a ball out, so there's only 8 balls in there. 4 of them are red now. That's 1 over 2. If the first one was red, there's only 8 balls left in the bag, and 3 of them are white. So now we've got 3/8. For some reason, this always happens when I draw 8s. 3/8. And first one's red, second one's white, 1 out of 8. Now, first one white, second one red, 5 out of 8. 5 red balls are left in there of 8 balls. Always with the 8s. Ooh, last go. Now, first one white, second one white. Now, 8 balls in the bag, only 2 white ones left because we've already taken one out. So this is a 1 over 4. And first one white, there's still 1 out of 8 green balls. Now, down here, first one's green, 5 out of 8 red, 3 out of 8 white. There is no chance that the second ball will be green if the first ball was green because we've taken them all. So we can write, right, we can sort of write our sample space down here, remember? So red has a probability of 5 over 9 times 1 over 2 equals 5 over 18. Right? The probability of 2 red balls is 5 over 18, right? That's 5 over 9 multiplied by 1 over 2. Now the second part here, the probability that the second ball is white. Well, come back here. Now, it's going to be this one, or this one. What's the probability of each of these? This is 5 over 9 times 3 over 8 is 15 over 72. 15 on 72. Over here, this is 1 over 3 times 1 over 4 is 1 over 12. And over here, I've got 1 over 9 times 3 over 8 gives me 3 over 72. So, without losing these numbers, the very last question for the very last example here, the probability, oops, just going to scratch that out there, the probability of second white equals, right, we said it's 15 over 72 plus 1 over 12 plus 3 over 72. Okay, and that equals, I'm going to pull out my calculator and work it out. Hang on. Okay, here we are. Moment of glory equals 1 over 3. That's the probability that the second ball is white. So here we go. Oop. Over here, my probability, I better write it in, equals 1. That'll be right. I have to play it right at the end. The last thing I want to write is 1 over 3. And it disappears. Well, you've seen it on the calculator. Quality work here. Stanwell, quality work. Rightio. So that's how we can use probability trees where our probabilities are not equal, where the probability of each outcome is not equal. Righto? We have to write the probabilities on the branches, and we multiply along the branch, right, to find the probability of that outcome. Righto, that's it. That's the last video. If something doesn't make sense, you can check it out, but of course, jot down the question, ask me in class. I'll see you there. Thanks, Year 11.